Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed exercise 13.2. Hope it was clear for you all. And in today's session, we shall discuss the conversion of solid from one shape to another. And we will also solve some questions related to that concept. Let's move on to the topic. Before starting the session, let's recall the formulae from the chapter surface area and volume. The first shape is cuboid. Length is represented by the letter L, breadth is represented by B, and height is represented by H. Then the volume is L into B into H. Lateral surface area is 2H into L plus B, and the total surface area is 2 into LH plus BH plus LB. Next shape is cuboid. The side of the cuboid is represented by the letter A. Then the volume is A cube. Lateral surface area is 4A square and the total surface area is 6A square. Next is a right circular cylinder. The height of the cylinder is represented by the letter H and the radius is represented by the letter R. Then the volume is pi r square H. Lateral surface area is 2 pi r H and the total surface area is 2 pi r into H plus R. Next one is a right circular cone. The height is represented by H, radius is represented by the letter R, and the slant height is represented by the letter L. Then the volume is 1 by 3 pi r square H. Lateral surface area or curved surface area is pi rl, and the total surface area is pi r into L plus R. Next shape is sphere, where the radius is represented by the letter R. Then the volume is given by the formula 4 by 3 into pi r cube. Curved surface area is 4 pi r square and the total surface area also the same formula 4 pi r square. Next shape is hemisphere. Like the previous one sphere, here also radius is represented by the letter R. Then the volume is 2 by 3 pi r cube and the curved surface area is 2 pi r square and the total surface area is 3 pi r square. Next, we shall discuss the conversion of solid from one shape to another. Here, let's take an example. We might have seen candles which are different in shape. Let's take a situation. Take a candle in the shape of a solid cylinder, melt it and pour whole of the molten wax into another container shaped like a rabbit. On cooling, you will obtain a candle in the shape of the rabbit. The volume of the new candle will be same as the volume of the earlier candle. This is what we have to remember when we come across objects which are converted from one shape to another. So this is one scenario which we are going to discuss here. We are taking a candle. First it was in cylindrical shape and we are melting it and just making or remaking into another candle, but the shape is different. It looks like a rabbit. First it was a cylindrical shape, the whole wax. How much volume of wax it was there? First, in case of cylindrical shape, the whole wax is converted or melted and just formed another candle which is having a rabbit, which is having the shape of a rabbit. So here one shape is changed into another, means cylindrical shape is changed into the shape of a rabbit. And what we have to notice is when a solid is changing from one shape to another, we have to come across objects which are converted from one shape to another. What we have to learn is the volume of the new shape will be same as the volume of the old one. The volume of the new shape will be same as the volume of the previous one or the old one. And another situation, if you check, when a liquid which originally filled in one container of a particular shape is poured into another container of a different shape or size, the volume remains the same. For example, here you can see this is a glass of water and we are pouring it into a cubical shaped container. So whatever water was there here in the cylindrical shape, the shape of the water was cylindrical. And when the same quantity of water comes into cubical shaped vessel, the shape of the water will change to cube. So the volume of the water remains same from one shape to another shape. If it comes also, even though the shapes are different or the solid shapes are different, the volume remains the same. And the next one, if you are having a cylindrical container and just both are cylindrical containers only, and this is somewhat the radius is bigger than the the next one. So when we compare this one and this one, here the radius is different, radius is more and the height is less, but here the radius is less but the height is more. So when the quantity of water, when a particular amount of water was there inside this cylindrical vessel or cylindrical container, the shape of the water is like the exactly same as the shape of the container. The same quantity of water when we pour into another container, when it reaches to this container, the shape will change to, or the shape will be same as the container which the water occupies. So but the volume remains the same. So here what we have to notice, when we are changing a solid from one shape to another, the volume remains the same. This is what we have to learn from here. Let us consider some more examples. Keep an ice cube outside the freezer for a few minutes. Then we can observe that the shape of ice cube is converted into liquid form. As we can store this liquid in containers like glass, which is in cylindrical shape. Hence, we conclude a cube which is solid shape is converted into the shape of cylindrical liquid container. In this way, there are real-time examples like when a solid cube of lead is melted, we can make spherical bullets. Gold biscuits are melted, we can make different types of ornaments. In all these examples, the shapes of solids are converted into another shape, but always the volume remains the same. Move on to the exercise questions. Exercise 13.3, first question. A metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder of radius 6 cm. Find the height of the cylinder. Let's go through the question again. A metallic sphere of radius 4.2 cm. Metallic sphere in the sense spherical shaped object which is made up of a metal. So metallic sphere of radius 4.2 centimeter. Radius of sphere is given to us 4.2 centimeter. Is melted and recast. Recast in the sense we are just making a new form or new shape into the shape of a cylinder. The new shape is cylindrical and the radius of the cylinder is given to us 6 centimeter. We are asked to find out the height of the cylinder. So let's visualize the question. There is a metallic sphere, spherical shaped sphere is there. There is 4.2 centimeter radius and it is a remaking or recasting into a cylindrical shaped container or something like, and the radius is given to you, it is 6 centimeter and the height is unknown to us and we have to find out the value of this h. And here two shapes are mentioned. First one is sphere, radius is 4.2 centimeter is given, and the next shape is a cylindrical shape and radius is given to us 6 centimeter and height is unknown. So let's take it as h. As we have learned in the previous slide that when an object is changed from one shape to another, the volume remains the same. Since the sphere is melted into a cylinder, volume of the sphere is equal to volume of cylinder. So we know that volume of sphere formula is 4 by 3 pi r cube and volume of cylinder formula is pi r square h. So let's substitute by using these two formulas. Volume of sphere 4 by 3 pi r cube. So here r is 4.2 centimeter. So 4 by 3 pi into 4.2 the whole cube is equal to volume of cylinder is pi r square h. So here only we are having r. So pi into 6 square into h. So h we have to calculate. Here 4 by 3 pi into 4 by 4.2 the whole cube into, here there is 6 square, his 6 square is 36 and here there is pi. So 36 and pi will come here in the left side. So that here this is in the numerator, when it comes to the left side it comes in the denominator, that is 1 divided by 36 pi is equal to h. So that is h is equal to 4 by 3 pi into 4.2 the whole cube into 1 divided by 36 pi, means just changing the order, that left and right, left hand side and right hand side we are just changing it, that's all. Here 4 by 3, here there is a pi, 4 by 3 pi, this pi, and here there is 36 pi, that this pi also can be cancelled. So pi cancelled. Then we will get h is equal to 4 by 3 into this 4.2. We can split it into 3. 4.2 into 4.2 into 4.2 into 1 by 36. Then here 4 and 36 we can cancel 9 times. Then h is equal to, we are having 4.2 into 4.2 into 4.2 by 27. That is equal to, h is equal to just 4.2 into 4.2 into 4.2, that is in the numerator, divided by 27. We can just factorize and write as 3 into 3 into 3. So 3 into 3 9, 9 into 3 is 27. Then just we can cancel this one each other, that is this 3 and 4.2 we can cancel and write 1.4, and this 3 and 4.2 will go 1.4 times, and here this 3 and 4.2 will go for 1.4 times. So h is equal to 1.4 into 1.4 into 1.4 we will get it. So h is equal to, when we multiply these three quantities, we will get as 2.744 centimeter. So please do not copy this answer. You are just requested to multiply these three quantities and write the answer. And here this is one way of calculation. Which one is convenient, that you can choose. If you know any other method, then you can just proceed with that. Here itself you can cancel pi, and some kind of calculation you can do here in the first step itself. So calculation is your choice, but you must make sure that you are getting the answer h is equal to 2.744 centimeter, and also you must make sure that all the calculations are done on the right side of your notebook. Next, we shall discuss the second question, exercise 13.3, question number 2. Metallic spheres of radius 6 cm, 8 cm, and 10 cm respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Here, metallic spheres of radii 6 cm, 8 cm, and 10 cm. Three spheres are there. So first sphere radius is 6 cm, second sphere radius is 8 cm, and third sphere radius is 10 cm. And these three spheres are melted to form a single solid sphere. And these three are melting, and we are just making a single solid sphere. And it is quite sure this is small one, this is a little bigger than the first one, and this is the biggest one among these three. And these three are making, and we will get a sphere which is bigger than all these three. So maybe we are just melting these three spheres and making a single sphere. Find the radius of that particular sphere which we are making. So let's visualize the question. There are three spheres. The first one is this one, smaller one, that is 6 cm radius, and this is 8 cm radius, and this is R3 10 cm radius. These three spheres we are melting and just recasting into a solid sphere, single sphere, which is somewhat bigger. And let's take this one as a radius R, because we don't know the value of R. We are asked to find out the value of R, or the radius. So let's take first sphere, then another one we can consider as second sphere, and third sphere. And we have to form a new sphere also. So these are the four categories which is given to you. So let's write the radii. First radius is 6 cm, second radius is 8 cm, and third sphere radius is 10 cm. And the new sphere radius we don't know, so let's take it as R. Then, since three spheres are melted to form a new sphere, we know that just when we are changing one shape to another, the volume remains the same. That means the volume of these three spheres will be same as the volume of the new spheres. Means when we add the volume of these three spheres, we will get the volume of the new sphere. So that is what here we have to write as a statement. Volume of three old sphere is equal to volume of the new sphere. So three old sphere, in the sense the three are having different dimensions. Let's write it. Volume of first sphere plus volume of second sphere plus volume of third sphere equal to the volume of the new sphere. So volume of the sphere, we know the formula, that is volume of the sphere is 4 by 3 pi r cube. Here volume of new sphere is equal to, just we are rearranging this statement because this is what we have learned, but for our calculation purpose we will go for a little bit of rearrangement so that it will be easy for us to find out the answer. So volume of new sphere is equal to volume of first, second, and third spheres together. That is equal to volume of new sphere. We know the radius is R. Just direct formula only, 4 by 3 pi r cube. That is the volume of sphere. Equal to volume of first sphere. That is 4 by 3 pi into Volume of first sphere is r cube. R cube is 6. R is 6. So 6 cube. 6 cube is 216. Plus volume of second sphere. Volume of the second sphere is 4 by 3 pi into r cube. Here r is 8. So 4 by 3 pi into 8 cube is 512. Plus the third sphere, that is 4 by 3 pi into 10 cube. R cube is 10 cube. So 10 cube is 1000. That is equal to, here 4 by 3 pi r cube is equal to, in these three terms there is 4 by 3 pi is common. Here I have avoided one step, the substitution part I have removed. If you just want to write it, that one you can write like 4 by 3 pi r cube is equal to 4 by 3 pi into 6 cube plus 4 by 3 pi into 8 cube plus 4 by 3 pi into 10 cube. That you can write if you want, it's not a problem. And here 4 by 3 pi we have taken as common outside. The balance is 216 in the first term and plus 512 in the second term plus 1000 is in the third term. Remaining 4 by 3 pi from each term it came out as common factor outside. Now 4 by 3 pi r cube is equal to 4 by 3 pi into, when you add these three terms you will get as 1728. Now 4 by 3 pi is common in both the left hand side and right hand side, so 4 by 3 pi is cancelled. Then r cube is equal to 1728 we have got. Then we have to find out the cube root of this term 1728. For that, what you have to do is, you have two options. Either you can go for factorization method or else you can just estimation way you can do. So I am just proceeding with the estimation way. So here r is equal to cube root of 1728, that is equal to cube root of 1728 is 12 into 12 into 12. This is the estimation way we have calculated. Those who feel it is difficult, what you have to do is 1728 you have to go for factorization. With the 2 we can factorize, and the prime factorization you can just do it, and you can just group it as pair of 3, and you can just conclude by finding out the cube root. So this is a better way if you practice. So r is equal to cube root of 12 into 12 into 12. That is equal to, here inside the cube root there are 3 terms. So one term will be coming out since there is cube root. So there is 112 is coming out. So radius is equal to 12 centimeter. So here the radius of the resulting sphere is 12 centimeter. So please note that in this type of calculations the concept is very easy, means the volume of an old shape is equal to volume of the new shape. But the problem here is the calculation part. So you must choose a better calculation method and you must practice it for just solving it in the examination time. Next we shall discuss the third question, exercise 13.3, question number 3. A 20 meter deep well with a diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So let's go through the question. It's a practical question. A 20 meter deep well with a diameter 7 meter is dug. Usually we are digging the well in the shape of a cylinder. The shape of the well is a cylinder. So 20 meter deep means height is given to us 20 meter and the diameter is 7 meter, means radius is 7 by 2 meter. So 20, this is in the cylindrical shape. Here deep is given. Deep is given in the sense usually well is below the ground, means underground. So that's why it is height is given to us deep, 20 meter deep, and 7 by 2 is the radius. And when we dig a well, usually mud we are taking out, that we call it as earth. So earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Means when we are digging a well, we must take out mud from the well, means we must take out earth from the well, and whatever earth we are getting, just we are spreading to form a platform. Platform means it is in the shape of a cuboid. The length of the cuboid is 22 meter, breadth is 14 meter, and height is missing, that we have to calculate. Here the situation is we are digging a well and mud what we are taking out from the well is spreading to form a platform. That is what the question. So let's visualize the question. There is a well, height is given to us 20 meter, means this portion is below the ground. So this is called here it is mentioned it is deep or depth. So height is 20 meter and here the diameter is 7, means radius is 7 by 2. So whatever earth we are taking out from the well, we are just putting it outside and making a platform, means which is in the shape of a cuboid. Length is 22 meter, breadth is 14 meter. Height is missing, that we have to calculate. So there are two shapes are mentioned. First one is cylindrical shape, diameter is 7 meter, radius must be 7 by 2 and height is 20 meter. And another shape is a cuboid, means a platform. It is a cuboidal shape and length is given to us 22 meter and breadth is 14 meter and height is missing, so let it be h meter. And here as per the condition, volume of well is equal to volume of platform. Volume of well in the sense whatever earth we are taking out from this well, only we are using to form a platform. So volume of this well, when the mud was inside this well, the shape of the mud was cylindrical. So that's what the volume of well is equal to volume of platform. So in another way, if you say volume of cylinder is equal to volume of cuboid, because well is in the shape of cylinder, platform is in the shape of cuboid. As we know that the volume of cylinder is pi r square h and the volume of cuboid is quite familiar for us, L into B into H. Let's substitute it. Volume of cylinder, that is pi r square h. Pi value we have to substitute because right side there is no hope for a pi because L into B into H. So there is no way of cancelling pi. So let's substitute it. 22 by 7 into radius is 7 by 2 square into height is 20 is equal to volume of cuboid L into B into H. So L is 22, B is 14 and height is H. That is equal to 22 by 7 into this 7 by 2 we can split. 7 by 2 square we can write it as 7 by 2 into 7 by 2 into 20 is equal to right side same 22 into 14 into H. Here 22 can be cancelled, both the side it is there. Next is 7 can be cancelled. Next these 2 we can cancel, that is 2 into 2 4 and this 20 we can cancel as 5. Then all cancellation is done. So left side there is 7 into 5, right side there is 14h. That is h is equal to this 7 into 5 divided by this 14 will come to the left side, comes as division because here multiplication comes to the left, it becomes division. So 7 into 5 by 14. Here 7 and 14 we can cancel 2 times. So 5 by 2 will come. So 5 by 2 is 2.5 meter. So we have got the answer. The height of the platform is 2.5 meter. Next we shall discuss the fourth question. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. Here, just like the previous question, we are digging a well and the diameter of the well is 3 meter and height is 4 meter. Depth is 14 meter. So the shape is like a cylinder, and while digging the well, we are just getting a particular quantity of earth. What earth we are getting is taken out and it has been spread evenly all around it. All around the well we are spreading in the shape of a circular ring of width 4 meter to form an embankment. Embankment means it is a raised structure around the well just to avoid accidents. Find the height of the embankment. That is what we have to calculate. Let's visualize the question. This is a cylindrical shaped well. Cylinder A we can consider, and the height is given to us 14 meter and the diameter is 3 meter. And while digging this well, we are getting a particular quantity of earth. Whatever earth we are getting, we are just spreading around the well to form an embankment. Embankment looks like this, means it is a shape of a circular ring. Circular ring in the sense you can see here, just there is one circle is inside and another circle is outside. So in between these two circles only we are just filling the mud. So this is called the circular ring shaped, that we can take it as cylinder B. So let's write down the given measurements for the case of well. Radius is 3 by 2, that is 1.5 meter, and height is given to us 14 meter. And in case of embankment, it is a circular shaped ring. There are 2 radii are there. So here first radius, that is called the internal radius, we can consider as R1, that is 3 by 2, diameter is 3 divided by 2, that is 3 by 2 is 1.5 meter. And here width of embankment is 4 meter. Width means this portion is width, means from the inner circle to the outer circle, the measurement is 4 meter. So the outer radius will be from the center to here. So center to here in the sense inner radius is 1.5. So 1.5 plus 4, that is outer radius. So external radius is R2. We can consider 1.5 plus 4. So 1.5 plus 4 is 5.5 meter. So here let's recall the formula, volume of cylinder A. So this is normal formula, normal cylinder, pi r square h. And this is a circular ring. Cylinder B is a circular ring. So the formula, we are using a shortcut here. Volume of hollow cylinder formula, that is equal to pi into R2 square minus R1 square into H. So pi into R2 square minus R1 square into H. So here R1, R2 changing also, it's not a problem. The first one should be bigger one and the second one should be smaller one. That is the thing. So here how we have got the formula, in the sense the volume of this shape is outside volume minus inside volume. So outside volume also cylinder only pi r square h, inside volume also pi r square h. So since there are two radii, one is R1 and another one is R2. So pi and h, if you take outside, pi h into R1 square minus R2 square. That is what the formula. So derivation is not necessary. You just simply by hearted this formula. Then here, since the mud of well is distributed in embankment, volume of well is equal to volume of embankment, that we have already discussed. So volume of well in the sense pi r square h, that is cylinder A, pi into r is 1.5 square into h is 14, is equal to volume of hollow cylinder, that is pi into r2 square minus r1 square. Even pi into r1 square minus r2 square into h also not a problem. It should be bigger one. First one should be bigger radius you have to put. So pi into 5.5 square. Here the bigger one is 5.5 square minus the smaller one is 1.5 square. So 5.5 square minus 1.5 square into h. Then pi and pi we can cancel it. Then 1.5 square into 14 is equal to 5.5 square. Just to multiply it, you will get 30.25 minus 1.5 square is 2.25 into h. Then 1.5 square into 14 is equal to 30.25 minus 2.25. When you subtract, you will get 28 into h. Then here 14 and 28, just cancelling time, we will get 2. So h is equal to 1.5 square divided by 2. Here right side 2 into h, the 2 comes to the left side, it comes as denominator or division. So 1.5 square divided by 2, that is 1.5 square, just to multiply it, or 15 square we know 225. So 1.5 square is 2.25 divided by 2. When you cancel 2.25 and 2, we will get the answer as 1.125. This is a complete division is possible. So just write the complete answer. Don't stop after dividing with one digit. 1.1 and all, please do not write. Complete division is possible. So 1.125 full answer we have to write. So the height of the embankment is equal to 1.125 meter. This is what the answer. We are asked to find out the height of the embankment. So we have got height of the embankment is equal to 1.125 meter. Dear students, today we have discussed the conversion of solid from one shape to another, and we have solved 4 questions from exercise 13.3 by using the same concept. Hope it was clear for you all, and if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.